believe is recording. All right. So guys, what you're going to, I'm going to just kind of show this one here. So got some sample data for us to take a look at and question on the graph. All right. So here, let's put this over. On our second graph, we've calculated our average. You add the three trials together, get a number, divide it by 3. All right, you do that for all of your trials. And then for speed, you're going to do the distance traveled, which is 2, divided by the average. So this one was 2 divided by 1.81, 2 divided by 1.64, 2 divided by 0.22, etc., all the way down. So these are what our numbers are for our speed. This is going to be going on our y-axis on the graph on the second one, the second graph. Okay, paper clips attached is our x-axis. So if I can just do this for a second. All right, this graph, they plotted their data points, all right, at the second paper clip. Okay, we were at a speed of about 1.1.
So what, you went up by 2 on the y, 0.2?
Yeah, on the bottom we would go up by 0.2, because on the top, going up by 0.1s, because like I don't think many people would have had a speed of over 3 meters per second. If you calculated a speed of over 3 meters per second on your first data table, you may need to go above, you may need to change it up a bit, maybe go to 0.2s.
So for the second one, up by 2, so it's 2.
Yeah, because right here they got above a 3, so if I use that same scale, like a data point or 2 wouldn't fit. So I changed that. Now, only thing I can say about their graph right here, data points look good based off of what we have. But it's okay because it's like one of our first graphs that we're doing here. This thing I gave to us the other day about graphing guidelines. Okay, we identify our variables. We have the range, determine the scale, which we were just talking about. Axes are already labeled. Plot your data points. Now, to draw the graph, okay, we are to draw a curve or a line that best fits the data points, or most of the data points, called a line of best fit. So you're not going to just connect the dots here. So there is an example of this guy. So you wouldn't have gone like, let me show it like this. You're not going to go connect the dots like that. It's not as good of a actual representation of your data and really to determine a overall trend. So to do that, what you should do is basically, here, I'll show you on this guy here. So instead of connecting the dots, all right, like one of our students did, it's okay. That's right. You're not 100% sure doing this. So, okay, come here. Why is my mouse bugging out? Slow it down. There we go. All right, that's kind of what they have right now. We don't necessarily want that. We want our line of best fit. So for a line of best fit, you are going to basically, it doesn't have to start on a data point, but it would go through majority of where the data lies. So I would say that this is probably your line of best fit. And this would be a better line to help wind up predicting the overall trend. And why or how is this okay? Well, if you kind of look at the space above and below this line, okay, like here we got one data point above the line, 2, 3, and 4. Down here we have kind of this 1, 2, and 3. But notice how these guys here are like spaced a little bit further away from the line. That's okay. All right, this should be somewhere along those lines. And why should this be somewhat of a straight line? Well, as you should have kind of looked or seen from our data table, and then also from the graph, All right, the idea of this and what we're trying to show was the relationship between, all right, adding more weight to the paper helicopter, paper twister. All right, by adding more weight with number of paper clips, you've seen that the speed wound up increasing. So it should be a directly proportional relationship, and a directly proportional relationship is like usually a positively sloped line like that. So basically that's saying as the one variable increases down here, all right, our other variable is going to increase as well. It's a directly proportional relationship. Um, and then what you would see for the wing, or kind of what you should see for the wing length, for just taking a gander at this real quick. All right, we're starting at 10 centimeters. So this is where, don't want you messing up on this graph. We're starting at 10 centimeters. We're at a speed of 0.888. So you're going to the 10 centimeters guy, and your first line would be not at quite at 0.9, but at like almost at that 0.9. So that'd be like my first data point. And that should be at the 10 centimeter guy. Then at 9 centimeters, I'm right around 1.05. So then I would go to the 9 centimeter mark. Okay, this should be like, this is 1.0, this would be 1.1, so it should be in the middle of those two. So make sure you're at the 9 centimeter mark. This is 1, this is 1.1. We will be at 1.05, so somewhere in the middle here. And then you continue on. My next one was like at 0.116. So if this dude here is 0.12, at 8 centimeters, I should be at 0.16, so almost at the 0.2, but not quite. Just a little bit right above halfway. Yep, sorry, should be on the 8. That's why we definitely want to use pencil as well. Okay, there's always going to be little mistakes that you have or may need to correct. Okay, and then you're going to plot your data points, and the same idea, you're going to do a line of best fit at the end. All right, so let me just kind of skim through this one so we can just kind of see what our vague line of best fit should be based off of this person's data. Okay, the next one at 7 centimeters, we are at 1.4. This is 1.3, 1.4. They're at 1.40 exactly, so right there. Then we had a 1.23, so based off of 1.23, so at 6 we're around here, just a little bit above the 1.2. Then we're at a 1.38, so we are just below the 1.4 line. 1.47, so almost at 1.5. Then we have a 2.17, so that should be up almost at the 2.2 mark. And then our last data point that we have here is a 2.6. Wait, no, that was 3. That's 2.6. So somewhere up around here. 2.6. This should be here at 2.17. I missed one data point. Let's see where. At 3, I should be at 1.47. So there. 1.38 should be my next one, which was here. 0.23. All right. Well, let's just say that these are our data points. Let's say that these are our data points. So we have this guy here. Let me see. Can I do this in a different color? So we got this point, this point, this point, this guy, this guy, this guy, this guy, this guy. And then we have 2 that are up decently high. So what happens is a line of best fit is used to try and help kind of eliminate certain outliers. So like if you look guys right here, this first string of data points is all pretty similar. All right, they're all around like this kind of a slope here. Right, we got like 1, 2, 3 above. We got 1, 2, 3 below. Like these 2 points are almost directly on it, and then you have these 2 guys that are way above. It's okay. It's experimental data, but like if you were to just always harp on those guys in particular, try and add them to your line of best fit instead of our line of best fit being like this. Those 2 things can cause it to skew the data a little bit. So those 2 outliers a little bit don't necessarily fit the overall trend of the majority of my data points. So I'm not going to take my line of best fit like this and go crazy like to up here. I'm going to kind of keep it along this spot. So, and if I did kind of keep it along this thing and I extrapolate it, right, I extend it, then what I should have been able to determine if I didn't do the 1 centimeter or 2 centimeter, all right, wings, then what I should have been able to kind of predict was that, at the 1 centimeter mark where I should have been somewhere in this ballpark of just about 2. And then the 2 centimeter, I should have been somewhere here about a 1.6-ish. That would have made more sense. So we use lines of best fit like that to help try and predict, all right, potential problems or potential questions like that, right? So if we stopped at this data point, we didn't do those last 2, we could have predicted that the last 2 would have been somewhere around here and here. Now, if you knew these data points first, plotted this line, all right, and did your line of best fit, even though these are 2 example or were our 2 data points, I would have maybe personally, I would have then reran a trial or 2 to see, if they would have wound up being closer to where our line of best fit would be for both of them. All right, so you guys, we're going to finish up both of those graphs for me, okay? Once we finish the graphs, we're going to answer the questions on the backside.